the second part of the question, um, it's at a different state. Temperature of water are supposed to be obtained when pressure is given. So we know that the pressure is 4 megapascal, and we know that specific volume is 0.07523 meter cubed per kilogram. Again, I don't know where in this curve this state is located. It may be to the right of the pink curve here, which means superheated, to the left compressed liquid, in between, which is mixture, or exactly on the lines. That's why again I start by using the table, the table that shows the properties of saturated water. This time pressure is given, and I use the pressure table. So pressure is 4 megapascal or 4,000 kilopascal. So be careful about the units here. So 4,000 kilopascal. Saturation temperature for this pressure, suppose that this pressure is 4,000 kilopascal. Saturated temperature for that, I'm going to call it Tsat, equals to 250.35 Celsius. Okay. Again, I compare the specific volume that I have with the specific volume of the saturated vapor and saturated liquid. Vg in this case is 0.049 and the V I have is 0.07. So I can say that V is greater than Vg. That's why I can definitely say that this is a superheated vapor. And since this is superheated vapor, I cannot use this table A5, table that belongs to saturated water, anymore. This is just to determine where this is located, what the state is. After that, in order to find the, let's say, the temperature or any other properties that we will study in future, and the temperature of superheated vapor at pressure of 4,000 kilopascal, I need to use the table of superheated water. For superheated water, when pressure is 4 megapascal or 4,000 kilopascal, temperatures are listed and the specific volume of each one is given to me. So in this case, we have specific volume that is 0.07523. So 0.07523. If you look at this table, definitely you will see that this magnitude 0.075 is between these two rows. So that I'm gonna highlight by, let's say, yellow and green. So in this case, we need to interpolate to find the temperature. How do we interpolate? I usually make a table for temperature and, let's say, volume. First, I know if temperature is 400, volume is 0.07343. If temperature is 450, volume would be 0.08004. Then I have a different case where I don't know the temperature, but I know the volume is 0.07523. So I add it here, 0.07523. Now you can use the calculator if you know how to use and how to use your calculator in order to interpolate. You can write the equations, or you can use any software, any website that does the calculation, that performs this analysis. So I just teach how to do it with hand calculation for once. From now on, I may use the website or a calculator, but here I need to say that 450 minus 400, the difference between the two knowns temperature, divided by T minus 400 equals 0.08004 minus 0.07343 divided by, so the difference, the numerator is the difference between two known specific volumes, and then the difference between the specific volume of unknown temperature 0.07523 negative 0.07343. We need to solve this equation in order to get the unknown temperature. Another way that we have is to use the website that I'm gonna post the address of the website in the video. So in this case, we are looking for x. Usually x refers to the column at the left and y refers to the column at the right. So the magnitude of the first x is 400. The magnitude of the second x is unknown, and the third x is known, 450. For y refers to the column at the right. So it's y1, the first number 0.07343, the second one 0.07523, and the last one 0.08204. So we press the bottom and the answer is 413.6. So temperature, unknown temperature, is 413.6 Celsius. That answer must be the same as the answer of this equation, this fraction.